Okay, we're going to start first by putting this in our notes. We want to talk about slope-intercept form of a line. A non-proportional, and make sure you understand that we're talking non-proportional here. Non-proportional linear relationship can be written in the form y equals mx plus b. The key thing to remember here is that in slope-intercept form, when an equation is written in that form, the m is the slope. So right here is the slope of the line, and b is the y-intercept. So right here is the y-intercept. So we can take a look at this and recognize that this right here is our slope, and this right here is our y-intercept. Okay? Make sure you have this in your notes, please. Example 1 wants us to state the slope of the y-intercept of the graph of the equation y equals 2/3 x minus 4. So when we take a look at that, remember that we can use this equation here, y equals mx plus b, and therefore we can take a look at m is right here and b is right here. Now remember that although our original equation said y equals 2/3 x minus 4, we can take a look at that and make that look like y equals 2/3 x plus a negative 4. So understand that when you take a look at this, that your b is negative 4 and your m is 2/3. And that's what we end up with down here. The slope of the graph is 2/3 and the y-intercept is negative 4. Let's take a look at another one over here. Let's do y equals 3/4 x plus 5. Think for a minute about what the slope would be in this particular situation. So we would write m equals the slope, and think about what the y-intercept would be in this particular situation. So we would have y, and if you want to abbreviate it like this, that's 5. Fine, we have y-intercept. So obviously m equals 3/4 because that is the coefficient. Remember, that's how we say that. That's the coefficient of x. And the y-intercept equals positive 5, and of course we can just write that as 5. Okay, please press pause and do A, B, and C. Now let's take a look at example number 2. Write an equation of a line in slope-intercept form with a slope of -3 and a y-intercept of -4. So in other words, in problem number 2, they're asking you to do the exact opposite thing they asked you in problem 2. In this case, they're giving you the slope and they're giving you the y-intercept, and you need to put it into the equation. And remember that the slope, -3, needs to go right here in our equation, and the y-intercept, -4, needs to go right there in our equation. And once we put -3 in there for the coefficient of x, and we could say plus a -4, but I would like you to learn to just jump right to this step here, where we put the -3 in for the coefficient of x, -4 here, and we get y equals -3x minus 4. Right here's our answer. Let's take a look at sample number 3. In this case, they're asking us to write an equation in slope-intercept form from the graph shown. And we're going to create an equation from that. The two things we need are slope and, of course, a y-intercept. So we take a look at the graph here, and right here we can see that the line travels through this point right here, and we can move from here up to here, up to here. We count that up and we go to 4. So our y-intercept is going to equal 4. The next thing we can do is we can start at this point right here and travel down to this point here. So when we do that, we're going to start right here, we're going to count down 1 unit as is shown right here, and we're going to count over 2 units as is shown here. Okay, so when we count down 1 unit and over 2 units, remember counting down 1 unit is a -1. So our slope is -1/2. So when we go to write our equation, our slope is here and our y-intercept is here, and we end up with the equation y equals 1/2 from our slope over here, y equals 1/2 x plus 4 because our y-intercept is 4 right here. Please press pause and do letters D and E. Okay, let's talk about our important concept here, and you are probably going to want to put some of this in your notes and on your gold sheet. When an equation in slope-intercept form applies to a real-world situation, this is really key here, real-world situation, the slope represents the rate of change and the y-intercept represents the initial value. Okay, so now let's take a look at what that means when we apply it to a real-world problem. So here's our real-world problem. We have the student council is selling T-shirts during Spirit Week. It costs $20 for the design, and it costs $5 to print each shirt. The cost, Y, to print X shirts is given by the equation Y equals 5X plus 20. Now they want us to graph Y equals 5X plus 20 using the slope and the Y-intercept. Recognize that we can just look at our equation. And our slope is going to be 5, and our Y-intercept is 20. So we need to graph the Y-intercept first, and that's going to be right here at 20. And then we have a slope of 5. So what they're showing here in the sample problem is moving up 5 because of our scale here of 5. Let's take another look at that where we can see it a little better. Our scale here of 5 from 20 up to 25, and our scale here of from 0 to 1. So our slope is up 5 and over 1. But here is what I'd really like you to think about doing. When you do this, count up 5 and over 1, up 5 over 1, up 5 over 1, and do it as many times as you can fit on the graph. And now I'm going to plot that point. So if I plot this point and this point, now when I draw that line, I'm going to be accurate. What many of you are going to be tempted to do is draw, let's say that these 2 points here were right here and right here. And many of you are going to be tempted to draw that line, and your line's going to look like that. And as you can see, my line is way off. If I keep going up and over, I should be more like right there. That would be a much better line. Make sure you go to the end of the graph when you're using slope in order to plot. Interpret the slope and the Y-intercept. The slope in this case represents the cost in dollars per T-shirt. And the Y-intercept in this case is the one-time charge. So now if we go back to our main concept up here, we can talk about the fact that the slope represents the rate of change and the Y-intercept the initial value. We have to pay for a $20 design fee. So right from the start, before we print a single T-shirt, we're going to cost $20. And then it's going to go up at $5 per shirt. So each shirt is $5. And that's why we have Y equals 5X, 5 times the number of shirts, plus the original $20 setup fee. The slope, again, is the rate of change, and the Y-intercept is the amount, the set fee that we start with. Please press pause and do letter G. Okay, here are your solutions to the letter problems. Let's first of all do letter A here. Okay, first of all, we're being asked for the slope and the Y-intercept. So the first thing we want to do is put M equals, and we also want to do a Y-intercept equals. Okay, and remember, in this form of a line, as long as we have its Y equals some amount of X plus some constant, plus or minus we could call it, we are going to easily find the slope here and the Y-intercept here. So our slope is the coefficient of X, and the coefficient of X is negative 5. Don't forget the negative. And the Y-intercept is at positive 3, so we're just going to write 3. So that is our solution to letter A. When it comes to letter B, again, we are looking for our slope and our Y-intercept, which are found right here for slope and right here for Y-intercept. So our slope, M, equals 1/4. And our Y-intercept equals negative 6. Now let's take a look at letter C. We have a slope right there, and we have an intercept, Y-intercept, right here. So we're going to, first of all, this is confusing to some kids, but remember that is negative 1x. So our slope is negative 1, and our Y-intercept is positive 5. Okay, our next problem is letter D, and they want us to, first of all, for D, they want us to write an equation in slope-intercept form for the graph. So the first thing we need to do is recognize that this is our y-intercept, which of course is negative 2. The next thing we want to notice is that we start on this line right here and we move up to this point right here, which would be right here. So we can count up and we can go 1, 2, 3, 4, 5. So our rise is 5. Let's do rise is 5. And our run, so we're going to rise over run. Our run is from this line here over to this line here, and we count that as 1, 2, 3. So our run is 3. So we have everything we need here. We have equation of the line is y equals negative 5/3 x minus 2. And next we can write an equation of a line in slope-intercept form with a slope of 3/4 and a y-intercept of negative 3. This is also quite easy. We have y equals coefficient of x is the slope, so it's 3/4 x, and we're going to subtract 3 because that's the y-intercept, minus 3. So this is your answer for E, and this is your answer for D. Okay, now let's take a look at letter F. First thing they want us to do is graph the equation, and this right here is the equation they want us to graph. So we have y equals 1/2. We could read this as 1/2 x, and that's actually better to think of that as 1/2. I'll explain in a minute. Plus 3.5, or $3.50. Okay, so first of all, we're going to find our y-intercept, and it's halfway between 3 and 4. So we've got a y-intercept right here of 350, and now our slope is up 1, rise of 1, and a run of 2. That's what 1/2 means. Okay, so first of all we have to look at our scale, and we recognize that our scale is in single units on both axes. So that makes this fairly easy to take a look at. From this point here, we're going to go up 1 and over 1, 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 up 1 and over 1. And this right here is going to be our point. And then after that, after we have that all set up, we put a straight edge on our page and we draw a nice straight line. And then the next thing we really ought to do is write y equals 1/2 x, or you could put 0.5x plus 3.5. That's what that equation, that line is. So it's labeled. Now all of these marks here where you move up and over, you obviously won't do those. I'm showing that so you see it. So you'd have a nice straight line through these 2 points. And remember, you go as far as you can out to the end, and you start here and you get a nice straight line through there. Now interpret the slope and the y-intercept. So let's take a look at what that looks like. If we interpret the slope was up 1 and over 2. So the slope was 1/2. So what did that represent in our problem? So what does that represent in our problem? First of all, there's a serious problem with this particular graph here. They don't have dollars labeled here, and they also don't have miles labeled here. But now that you see that, you can recognize that 1/2 means that we're going to pay $1/2 per mile that we are driven in the taxi. So the 1/2 represents 50 cents. Oops. 50 cents, so we could go $0.5, or we could literally say 50 cents per mile. That is what the slope means, 50 cents per mile. And what does the y-intercept means? It means that when we get in the taxi, we are going to pay $3.50 before we even go anywhere. And then additionally, we're going to pay 50 cents per mile from that point on. So the slope is the per mile charge, and the y-intercept is the initial charge. Please press pause and do guided practice.